Okay, we have done the question number 18. Sorry, 16. I think. Now we are doing the question, the unit 5, energetic question. We have done the question number 16. You are clear, right? Question number 16, the boiling point of the liquid. Yes, guys, I need answer. It's clear, right?
Yes, madam.
Yeah, this question is correct, right? Clear. So we'll move on to the next question. Next question is 26.
Madam, shall we do that again?
Which one? 26.
Yeah.
That's why I asked Mr. Mahdi. Okay, fine. We'll do because yesterday I was jamming her. So actually, do you know anything about what is that? Born-Haber cycle? Any idea? Yes, Abdullah. So anyone can try
On
this.
that day only, they gave first time COVID-19 holidays, madam.
So you didn't study. Is it so? Okay, so this is what. I'll stop sharing the question number 26 that we are going to do, right? You might have the paper. I will share the whiteboard now. Yes. Yeah. Okay. Simply I'll say about the Born-Haber cycle. Born-Haber cycle. Mahdi? Ah, give me a second. Any idea about the Born-Haber cycle? Come on. Clear about the enthalpy, definitely you will get the structure, essay question, MCQ, minimum, maximum 5, minimum is less than 5. At least it should be about 3. Now 1, 2, 3, 4. I have seen 4 question in not 4 even there. 5 question also there. You will see. Okay, still I will check. So at least 5 question I have seen. That means definitely you should know the unit 5. Any idea? Yes, Mahadev? Whatever you know, whatever you know, you can tell me. Yeah.
Madam,
Yes. Yes.
madam, in Born-Haber cycle, it's like
Not bond. Bond. BOR.
yeah, Born-Haber cycle. Madam, it
Mhm.
is like if there is Mg, we
Mhm.
can decompose it to Mg plus and 1 electron.
Mhm. So
And if there
actually,
is Mg plus, it will be equal to Mg2 plus and 1 electron like that.
so you are talking about the ionization energy. Indirectly, how to find the Born-Haber cycle? Actually, what is the major action of the Born-Haber cycle? Yesterday I have just said the word. I'm really sure you are not aware about that. That's why I said we'll do again tomorrow. So what we are studying under Born-Haber cycle, we are speaking about the lattice enthalpy. Lattice enthalpy of solid. What is mean by the lattice enthalpy? Here we are talking about the lattice enthalpy or lattice dissociation enthalpy. Can you define this word lattice word? Anyone? Yesterday I just said it. So the lattice
Yeah,
enthalpy.
you're asking the meaning of lattice.
Yeah, how it's formed. So what is the basic of the lattice? The giant structure, right, which able to form, right, the positive and the negatively charged, which held together. Okay, I just write the example. When you speak of the sodium chloride, it's a kind of the lattice, right? So the positive and the negative all together. So this is not, it will like this, the formation of the lattice we are talking. So how is happening? So by connecting, so more and more it is able to form the lattice. So the major part is you should need cation and anion, the dissociation of the ionic state. So what is the definition of the lattice enthalpy of solid? The enthalpy change, you can say that is the enthalpy change when 1 mole of the enthalpy change when 1 mole of a solid, the word is very important, the solid ionic compound is completely separated into gaseous. The words are very important. And yesterday I just told about this. Actually, I finished. The enthalpy change. So again, so what is mean by enthalpy change? Delta H, right? The words are very, the phrases just go through. The 1 mole of solid. Okay, we'll speak about the sodium chloride. That should be 1 mole. Okay, that should be solid, which is completely separated into gaseous ion. What is happening? You should go for the complete separation of the gaseous ion. This is what called the bond dissociation of sodium chloride solid. Are you clear about this definition? This 1 mole gaseous ion. This is what you have to understand first. What we are studying in a bond cycle. Just go through, guys. Give me a second. I'll be back. I want to detect the. Don't test my dad. Just give me a second. I'll be back now. Right.
Adir,
Why, boss?
whether the recording is going.
Yes, yes, yes.
Mm. Day before study, did you go to that organization?
Which one, ba?
Day before study, some of this was.
Ah, yes.
நான் ஃப்ரிட்ஜ் இல்ல உள்ளுக்கு செக் பண்ண நான் செக் பண்ணிட்டேன். நீங்க வைக்கிற இடத்துல கொஞ்சம் பாருங்க. செக் பண்ணிட்டு சொல்லுங்க நம்ம. Okay, guys. Did you all understand what is mean by lattice enthalpy of solid? Or
Madam, what
simply,
happened to principal, madam?
wait, I'll stop recording.
Madam, this dissociation means it will become plus and minus.
What is the plus and minus? Ions, cation and anion. Your solid, your lattice, right? Dissociated into what? The gaseous ions, positive and negatively charged ions. How can I say that? So that should be converted into what? Gas, not solid or whatever, or aqueous. That is also wrong. Are you clear?
Yes,
Fine.
madam.
So actually, the lattice dissociation enthalpy or lattice change of the enthalpy could not measure directly. That sake only we are using the Born-Haber cycle to find the lattice dissociation enthalpy of any solid. Did you all understand? So what is so this is the reason why we are using the Born-Haber cycle. The Born-Haber cycle, which is consisting the different steps of the enthalpy reaction. The one is what like Abdullah said. The first enthalpy should be, you are able to understand the formation of lattice. That is definitely should be there. One. And next, if it is solid, you should end up with sublimation reaction. Right? If it is what? The molecule of the gas, you have to convert it into the one atom gas. So the atomization. Once the sublimation or atomization, our concept is you have to convert into the gas. We done that part. Next, we have to convert into the ion, positive and negative ion. For positive, we are telling is first ionization energy. When you say for the negative, we are telling that is first electron gain energy. So if it is calcium chloride, so you know what is the formation? Calcium 2 plus 2Cl minus gas. Right. So here, what should be there? The calcium solid should be transferred into gas first. Then next, calcium plus, but we need the 2 plus, again you should transfer. So what should be this transformation? The calcium solid to gas is a sublimation. Gas to positive charge, ion, it's the first ionization energy, IE. And the second, right, the positively charged turns into the 2 positive charge. So you have to mention second ionization energy. Are you all clear? Are you all clear?
Madam will do for another example.
Okay. So what about the sodium, magnesium? Okay, magnesium chloride. Yes. What is the okay? Okay. Can you write the lattice dissociation reaction for the magnesium chloride? Lattice dissociation reaction. Questions are there. One is lattice dissociation reaction. What was our question? Is sodium chloride. Okay. One is the lattice dissociation reaction. Second one is the formation reaction. Formation of magnesium chloride. Third. Okay, can you write these two reactions now? What is the lattice dissociation reaction of the magnesium chloride? Anyone, write on the board. Quickly.
Madam, Mg plus.
Mg plus. Then you said
Mg 2 plus.
that is very important. This is a solid. You have to mention. Okay, that is not Mg plus. That is Mg2 plus. That should be gaseous state. Plus. Yes.
2 Cl minus.
So this is what is very important, guys, right? According to that, what is mean by the delta change or enthalpy change of the lattice energy, that you can write this is as delta HL, lattice energy, right? So that should be, what is your reactant should be 1 mole. So this should be definitely 1 mole, right? And it should convert it into the ions, positive and the negative ion, and definitely that should be at gaseous state. This is what your lattice dissociation reaction of the magnesium chloride. Can you write the formation of the magnesium chloride, sir? Formation reaction. That is, you can say delta H theta. If I put the theta, it's a standard. If I didn't, you can say just theta, just enthalpy change. Doesn't matter. Yes? Formation reaction? Anyone? Can say, I will write. You can say
Mg
the
solid.
okay, Mg solid. Yes.
Mg plus electron.
Mg plus.
No, aroma.
Yeah, I just Mg plus. So this should be gas. Are you telling this is the formation of the magnesium chloride or the first ionization of magnesium? Yes. You are telling this is the formation of the magnesium chloride. Even though this reaction is not the first ionization of the magnesium, right? The magnesium should be at the gaseous state, not a solid. So this is not the first ionization energy, but Mahdi right? So the formation of the reaction, the word is clearly simply said you. So look at here, the formation, how the magnesium chloride is formed. So you need the magnesium chloride, right, as your reactor, and that should be solid state. And always when you speak about the formation of the formation reaction, always the product should be 1 mole. That is right. Here When you take the magnesium chloride, you have what are the elements? Magnesium and the chlorine. And what is the origin of these two elements? Magnesium in your atmosphere or environment, it appears as a solid only. It's a kind of the solid. It's not a gas. So you can write that it as a magnesium solid plus. And chlorine, how it's appear? Can you say the chlorine atom in your atmosphere, in your nature? Or chlorine
Cl2
atom?
gas.
Yes, that should be a molecule. So you can write that is with their original state. That phrase is very important when you're writing the formation of any substance, right? So that what should be there, your original state, how it's appear in your environment, atmosphere. That state should be prescribed, not the gaseous state. The magnesium you can see, yeah, it can be seen as a solid as well as the chlorine. Chlorine always is a gaseous molecule. It's not an atom, right? So that should be gas. So I say it's a molecule. If the reaction is balanced, if the reaction is balanced, not right.
Yes.
Okay. Huh? Yes. Yes. Okay. Now the reaction. Sorry, the reaction is balanced. So what about this? We go to another example. Then only I can speak about that. So can you write the formation reaction of the sodium chloride now? Yes. Yes. First thing you're able to write the formation reaction. Yes. Quickly.
Na solid.
Na solid plus
Cl2 gas.
Cl2 gas. Okay, NaCl2. Is the reaction is balanced? Is the reaction is balanced? Yes.
No.
So how can you balance? Where you want to put the number? Any idea? Sodium 1, sodium 1, right. But chlorine you are having 2. Shall we put 2 here and another 2 here? Is it correct? Yes. Is it correct? At least say correct or not. I will say the reason.
Not correct.
Why? I said that I will say the reason, right? Okay, whenever you write the formation reaction, your product, what you're forming is should be 1 mole under standard condition. Right? So this should be definitely 1 mole, therefore you could not put 2 here. So therefore you can put half here. Now the reaction is balanced. Did you understand? Let's say write the lattice enthalpy change of this sodium chloride. That is enthalpy change. Delta H theta L. Yes. What is the reaction? That is dissociation of the sodium chloride. Yes. Quickly. Yes, quickly. The sodium chloride solid dissociated into what? The gaseous ion. This should be, your lattice should be in 1 mole for your gaseous ion. Yes, Na plus. Yes. Cl minus F. Are you all clear? Are you all clear? So what is our concept is? Under Born-Haber cycle, what we are definitely speaking is, you have to find the lattice enthalpy change from the change of the formation of the reaction. From this reaction to this is your target. Right? Did you all understand? So your question is based on which of the following reaction step is not present in the Born-Haber cycle of formation of sodium chloride solute. So what is the Born-Haber cycle? Why we are using the Born-Haber cycle? To determine the dissociation, the enthalpy change of the lattice dissociation. Right. So for that sake, we definitely need the formation of the sodium chloride. From the formation of the sodium chloride, we are going to find what the lattice dissociation is. So they have given what 5 reaction. One of the reaction not the answer, not an answer. So how do you find it? Let's do the Born-Haber cycle for this particular question. The question number 26, yes. The formation of sodium chloride. Sorry. Using Born-Haber cycle. So, Born-Haber cycle, definitely it will speak about what? Yes? Your lattice enthalpy change. So, first you have to write the formation reaction. What is that? Sodium solid Cl2 half Cl2 gas, which will give sodium chloride. Sorry. This is what we are dealing as delta H2. And I will write the final step. This is what delta I need. The answer is yes, lattice enthalpy change. Right. What should be the reaction? I will write here and here. Sodium chloride. Sodium chloride is dissociated into Na plus ion, Cl ion. I'll just do this. Let's reconstruct the cycle. Okay. The first step is you have to convert, just keep these two. Look at. You have to transfer the sodium. Okay, I'll write down, okay. The sodium solid to sodium gas. The first step. Then the sodium gas to. Give me a second. Yeah. Give me a time. I just call the sir and come back. Later,